Our next shape that we're going to talk about today is going to be our trigonal pyramidal. So far we went over the two variations of our linear shape. We went over the two variations of our bent, our trigonal planar. Now we're going to discuss trigonal pyramidal. So trigonal pyramidal is pretty straightforward, also just like the trigonal planar. It has 3 bonded atoms with 1 lone pair. A good example of our trigonal pyramidal would be nitrogen trifluoride. Here, let me redraw that because that guy sucks completely. All right, so when I'm drawing my Lewis structure for nitrogen trifluoride, if you notice, nitrogen comes first. He's also the least electronegative out of the two, so he's going to go in my center. Nitrogen is in group 15, so he has 5 valence electrons. And then we have fluorine, and fluorine is in group 17, so they all have 7. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Put my bonds in between them. So here's my ridiculous Lewis structure for nitrogen trifluoride. If you noticed here, he has 1 lone pair here at the top. It's a big old lone pair. And then he has 1, 2, 3 bonded atoms. This would be a trigonal pyramidal shape. If you're trying to picture the shapes themselves, think of it as anything with a lone pair is going to push down these molecules and give them a more bent shape or more pyramidal, like pyramid type of shape, because of this big repulsion that these lone pairs have on the central atom. That's why with your bent and with pyramidal, they're more of a 3D shape, more of a non-planar, non-linear shape. So our last one we're going to go over is tetrahedral. And tetrahedral is also very simple. It's just straightforward. There's only one variation. And that's going to be, as I make them all disappear, come back. So with this guy, he only has 4 bonded atoms, and he doesn't have any lone pair. Super simple. A really good example of a tetrahedral to use would be like methane or carbon tetrahydride. So carbon would go in our middle. He has 4 valence electrons, and then we have our hydrogens surrounding him. And draw my little lines here. Carbon's octet is full. Each one of the duets on carbon is full, on hydrogen is full. If you notice, this carbon has no lone pairs, no electrons hanging around. Everybody's paired up, everybody's full and happy, and it's tetrahedral. It has 1, 2, 3, 4 bonded atoms to the central atom. So just a quick review, you need to know 5 shapes. You need to understand the linear molecular geometry, the bent, trigonal planar, trigonal pyramidal, and tetrahedral. So remember, when we're going over each of them, and you can go back and rewatch that first video, probably pretty rough, but gets to the point. So we talked about the 2 different variations of our linear, where we could have something like a diatomic molecule, like H2, or we could have a more complex molecule like CO2, where you can either have 1 bonded atom or 2 bonded atoms. And that would both be examples of our linear. They don't have lone pairs on them. Bent can have 2 variations. We went over silicon dioxide as an example for bent shape with 1 lone pair. And we also went over water, which is a great example of bent with 2 lone pairs. Went over trigonal planar, and the example we used was boron trichloride, BCl3, because he had the 3 bonded atoms, no lone pairs, and then trigonal pyramidal we also went over. And trigonal pyramidal had the NF3, where our lone pair were on our nitrogen atom. We had the three fluorines floating about it. And then my tetrahedral that was up here, tetrahedral, remember we just had 4, which was our methane, our carbon tetrahydride, and he had 4 bonded atoms, no lone pairs.